Hey guys, today's show is about blockchain security tools. I had another show on 8th of April in which I spoke about blockchain security and what are the security impacts of blockchain and how they should be addressed. In this show, I will be delving deeper into what other mechanisms are available to improve the security of the blockchain. As you guys are aware, blockchain is an environment where currently uh, most of the deployments are on the public side, which means there are nodes that are owned by anybody and everybody, and the blockchain is sitting on those nodes. And so far, none of that environment has been compromised. No one has been able to modify the blockchain because of the network effect, and that's what's keeping the whole blockchain environment going without any requirement for extra security, whereby you don't need to have a secure session to the blockchain when you're transferring data. It all happens over HTTP. Blockchain has not been hacked. All the issues have come from the wallets or the other pieces way on top of it, and that's why to make it a bit more easier to explain, I have broken down the a typical blockchain ecosystem into four layers. Um, Looking at layer number one, this is what I call the cryptographic functions and consensus. So as you know, a blockchain is a chain of blocks that are using a cryptographic function of hashing, and that's how they're linked to each other. So you cannot go and modify a block that has already been committed via consensus to the blockchain because there's so many other copies available of it. You will not be able to successfully change that block. And the next level up is the layer two, where the code of in a particular blockchain gets executed. So this is the world computer, as they call it, which is sitting on every node that is supporting that particular blockchain ecosystem. On top of that, and sorry, before we go to this third layer, layer two would be pieces such as the Ethereum EVM that runs the smart contracts written in Solidity, and for the Bitcoin blockchain, this would be the code that's written in a script, and this is where it would be executing on. The next piece is layer 3. Up above that, the API. This is the interface that allows external parties to communicate with the blockchain. The main users are the wallets, which are communicating to the blockchain and sending transactions um, back and forth. The next piece are the smart contracts. So people develop smart contracts. Let's talk about Ethereum again, Solidity. So once you write the code in Solidity, it goes through the API, gets converted into bytecode, which then gets added to the blockchain for execution in the EVM. And then there's other uses as well, where people are using this similar API for walking through the blockchain, which are called blockchain explorers, to identify transactions as to who's sending what where, that kind of stuff. So as you can see, the biggest issue over here is this layer 4. The layer 3, 2, and 1 are pretty protected. They have never been compromised ever, although the blockchain runs in clear. The communications are all in clear. Um, the only thing different uh, people are doing to make make this environment secure, layer 1, 2, and 3, is that let's say Bitcoin blockchain uses script uh, programs that run, but script programs are not Turing complete. What that means is they don't have any if-else conditions that could cause race conditions, and which might cause the machine, the world computer to crash. So that's how Bitcoin blockchain is protecting their environment. For Ethereum, the way they are protecting is their code, the Solidity code is Turing complete. What that means is it has if-then clauses, it is able to make decisions, and and the way Ethereum addresses that issue is that if you want to execute this code, you got to pay some money, which is gas. So as long as you keep putting gas in into your code will continue running no matter what conditions you have in it. So you are the one who gets penalized for it. Um, so that's the protection mechanism that blockchain has. So moving right along, some of the solutions that are available to address the weakest link um, is the piece where any of the environments for blockchain that have come up, they have introduced their own programming language. In terms of Ethereum, they've introduced Solidity. Blockchain has introduced Script. So the biggest issue is both these languages are pretty new to the developers. The developers currently are familiar with the regular programming languages, um, C, C Sharp, C plus, Java, JavaScript, Go language, which Google introduced, and as a result of the network effect that these languages have behind them, um, people have been able to produce tools to implement secure coding practices. There are tools available to do code reviews. There are tools available to do penetration testing from outside, um, to make sure certain aspects of the code don't get exploited. The coding uh, constructs are all secure. They're all hacker proof. Um, so um, so in spite of the fact that these well-established programming languages have all these tools available, we still find issues with them. There's still vulnerabilities that get um, identified and people exploit them. So imagine something like something that is as new as Solidity and Script. Not a lot of people have experience in them. Plus, there's no tools that support them or understand them. So there's some tools that some enterprising groups, individuals who are dedicated to this cause have come up with. Um, One of them is Open Zeppelin, which introduces some libraries that you can include in your Solidity code to check for um, data input and data manipulation uh, issues. So this is readily available to anybody who wants to use it. So just include these libraries in your Solidity code and execute, and it takes care of all the legwork, avoids you from writing code to check what's being input and what kind of output you're getting. The next team that I want to talk about is Trail of Bits. These guys by far have had the most input into this security ecosystem of blockchain. They have come up with a lot of tools. You can go to this link over here that'll take you to their web page, and it'll walk you through all the tools that they have, everything that they do. I won't go through the details of each of these tools, but they have tools which do static code analysis on Solidity. They have a repository that has all kinds of gotchas that they've come across to that people can learn from and implement in their code. There is these two programs that are available that allow you to test your code as you are um, compiling it, as you are coding it, create test cases in different scenarios. Um, Trail of Bits also has a tool that allows you to reverse engineer the Solidity code from the bytecode. As you know, when you publish Solidity code to the um, Ethereum ecosystem, it goes in and it gets converted from Solidity into bytecode, which is again available on Blockchain Explorer if you wanted to, but it's not human readable. So they have created a tool that that does that, and they have a bunch of other tools as well, again available at the site. You can go further and investigate and check it out. Um, the next bunch of tools, I might call it, is coming from the NCC group, um, and these guys have come up with a list they call decentralized application security project top 10 list. So this one again is talking about just like um, Trail of Bits has a repository of issues that they've encountered and they would like people to keep an eye out for. These guys, the NCC group, have done a similar thing where they've made a top 10 list, just like the OASP top 10 list, and they've come up with this list where they identify issues, the examples, and how to address them. So if you are putting something together, make sure you take a look at this. The next tool is called Porosity, which is again a decompiler, just like what Trail of Bits has produced. It does exactly the same thing. It goes in, picks up the bytecode, and decompiles it into Solidity code, which you can read and figure out for yourself. So it makes it easy for somebody to understand what the code is doing rather than relying totally on GitHub repositories. Um, then that was it from the tools perspective. The other approaches that some people are taking are, I call them shims, which is pretty much trying to improve uh, or trying to address the gaps that existing environments pose. IV is again a language which is going to provide Bitcoin script developers with some high level better tooling for coding. The next one is Simplicity, which has been released by Blockstream. Again, it is one of those similar to IV, but it provides you that additional support for Ethereum's EVM. Then there are other approaches where um, there's digital asset modeling language by Elevance, which is a financial service industry focused smart contract language. And so there's niches which are coming up to support different environments. So Microsoft Cocoa framework is the one that's trying to introduce governance into the blockchain ecosystem, and they're also saying that they will provide a a network which allows a typical blockchain to scale further. So Microsoft is also trying to dip their tip to dip their toes into this blockchain ecosystem. Let's see how far they go. And with that, guys, that's all I had in terms of the blockchain tools. I will keep updating this blog post, and maybe I will also make another post with more details as I find out. Um, In the coming weeks, I will also be posting a discussion with one of my buddies about how you look at blockchain security. So we will be presenting two different views. One of them would be my view. Things are normal as they're progressing. Just what I had written on my blog post on the 8th of April, and his viewpoint is going to be the other side of the thing, like security impacts on the blockchain, what we should be looking out for, all the other sides. So it's going to make a good discussion point, something good to listen to, and as usual, feedback is welcome. Thank you very much. Have a nice day. Bye bye.
Please like, subscribe, and share the content in your social circles. If you want to contact me, my contact details are on my website, secunoid.com. The address is also at the bottom left hand corner of the slide deck. Um, and finally, the information I have shared should not be used as financial advice. Play the cryptocurrency investment game at your own risk. And lastly, thank you for your time, and talk to you soon. Bye bye.